Hello, this is Miss Cliffner with your lesson for Tuesday, February 15th. Take out your planner, write down the homework. It's 7.3C. It's a formative assignment, and yes, you're going to need to show your work on some of the questions. There is a retake for the Chapter 3 test this Thursday, the 17th. I'm up to date on grading in PowerSchool, except for I have not entered Friday's homework. So check PowerSchool. Okay, here's the warm-up. There's two equations to solve. Go ahead and pause the video and try these on your own. Okay, the opposite of dividing by 5 is multiplying by 5, so I'm going to put a little multiply by 5 over 1. I'm going to put a multiply by 5 here. Drawing my balance scale. 5 divided by 5 simplifies to a giant 1. That leaves me with x equals 10. When I check it, I plug in place of the x, I'm going to put in the solution of 10. So I rewrite the equation, 10 divided by 5 equals 2. So this is where I plugged in that 10. And then I do the math on both sides, and I get 2 equals 2, check. Okay, the next one, if you notice that the operation, a number next to a variable, means times, the opposite of multiplying is dividing. I'm going to divide both sides of the equation by 4. 4 divided by 1 cancels out. This side is 5, so I get 5 equals y. And when I check my solution, I plug in the value of y. I'm going to plug in a 5. So I rewrite the equation starting with 20 equals 4, but instead of times y, I put in times 5, and then I check it. Does the left side equal the right side? Yes, it does. Okay, the more we practice those, the better you get. All right, so today we're going to be looking at some word problems and sort of some real life examples and how you write and solve equations. Okay, so here's an example of you're buying a rug and it's 24 square units. And you want to make sure it's going to fit, right, in the space that you're putting it in. So you know the width is 6 units. What's the length? Right, and solve an equation for the length x. So I'm just going to label, if I have a picture in front of me, I label this with my W, and I label this with my length. And remember, area is length times width. So I'm going to go ahead and write area equals length times width. And then remember, I'm telling you that you need to define your variable. And so x is this. It's the length, right? The length of rectangle. Okay, so the equation I'm using, obviously, is going to have to do with the area being length times width. So let's do I could do the x times 6, right? But if I do this, that's a little awkward. I always want to put the coefficient, the number in front of the x, so I'm going to write it like this. 6 times x equals 24. Because remember, there's the commutative property of multiplication, so it doesn't really matter if you write x times 6 or 6 times x. Just the convention is to put the number in front of the variable. It's a multiplier. Okay, so now under the solution, I'm drawing my balance scale. I look at the side with the variable, and I want to undo the math that's happening there. This is multiplication, so I'm going to divide by 6. This is the giant 1. I get x equals 4, and then I'm just going to go ahead and write the word units. I don't know if it's feet or inches with this example. Okay, so now, so here's an OYO. This time, notice we have the length, and I'm asking you to find the width. So go ahead and pause the video. Please define your variable, write an equation, and solve it. Okay, so let's see, x, this time x is the width of rectangle. Okay, same type of equation, right? Area equals length times width. So if you want to, you can put the 176 first, and then it's the 16 times x If I have multiplication, the way that I undo multiplication is to do the opposite. Divide by 16, divide by 16. You can get out a calculator, and hopefully you come up with 11. So 11, I'm going to write in units, equals x. Okay, on this one I didn't ask you to check it. All right, so here's some more examples. Hey, 3 robots go out to lunch. They decide to share the $11.91 bill evenly. How much does each robot pay? And I'm already telling you that the definition of my variable is x is how much each robot pays for lunch. So remember, I always look at the question, and that if that's the question I'm trying to find, that's the variable that I'm coming up with. And you know, maybe you could have used p for pay, but I just used x. Okay, so I'm going to circle the 1191, and I'm going to underline share evenly. Okay, so share evenly to me means a division problem, but since I'm going to write this as an equation that you need to solve, like hopefully this is what you're thinking. I'm hoping you're thinking, if I take the 1191 and divide it by 3, that's what each robot is going to pay. So I'm going to kind of work it from a different direction and say this. Well, if I have 3 robots that are each paying X amount, that's equal to 1191. And then I look at the side with the variable, and it's going to match the equation up there. The difference between these two equations is this equation up here, there's really nothing to solve. There's just math to do, right? It's not like x is unknown at this point. X is 1191 divided by 3. So when I write it like this, then it's a little more challenging for you to solve. 3 divided by 3 is 1. I get x equals, and of course we can use calculators now. Hopefully you got $3.97. And then when I check it, I plug it into the equation of 3 times 3.97 equals 1191. And there is the value that I plugged in, right? That matches the x. So notice the structure of what I'm doing is this. I'm taking this original equation and I'm just rewriting it, but I plugged in the value of 397 that I think makes the equation true. And then I check it, and I use my calculator, and indeed 11.91 is equal to 11.91. Check. Okay, next. Here's another robot. This one says, on Earth, objects weigh 6 times what they weigh on the moon, and a robot weighs 96 pounds on Earth. What does it weigh on the moon? So I kind of went back to my question and I underlined, what does the robot weigh on the moon? So I used W for weight, and I put under my definition that W is what a robot weighs on the moon. And then I'm going to circle the important information and go back and see if I can make sense of it. Okay, so 6 times objects weigh 6 times what they weigh on the moon. So a robot weighs 96 pounds. Oops, I'm going to circle the 96 pounds on Earth. And then it says on Earth, so it's kind of like the 96 pounds equals, so I'm thinking something like this, 96 pounds equals 6 times what the robot weighs on the moon. Or if you prefer, you can do 6W equals 96. Okay, now I'm going to solve it. Again, this is a multiplication. The opposite of multiplying is dividing. I'm going to divide by 6 and divide by 6. And 90s, let's just do this. If you don't have a calculator handy, 6 goes into 9 one time. When I subtract, I get 36. 6 goes into 36 6 times, and I have no remainder. Okay, so the answer is 16. And it's 16 what? Let's see. 16 equals W, and it's 16 pounds. So let me go back and make some room for the units in my answer. 16 pounds equals W. And now when I check it, remember, I'm going to take the original equation. Let me do this. Here's my original equation. And there's my W, and in place of W, I'm going to be putting in 16. So I do 96 equals 6 times 16. I can do the math over here. 6 times 6 is 36. 6 times 1 is 6 plus 3 is 9. It works. 96 does equal 96. Check. Okay. Now I have a couple of OYOs. Try this on your own and unpause the video. There's 2 OYOs. Okay, so I'm going to circle the U and 4 friends. And I'm going to make a little note. That means there's 5 of us, right? You're going to buy tickets to a baseball game. Total cost, $70. I'm underlining total. Write and solve an equation to find the cost of each ticket. Okay, so let's see. I used C. C is cost of 1 ticket. Okay, so I usually think about the price of 1 ticket times how many tickets you need. So I usually write equations of situations like this with the number of tickets I need times the cost equals the total. And then to solve it, right, do the balance scale, look at the side with the variable. What's the opposite of multiplying by 5? Dividing by 5. And then 5 goes into 50 10 times, and then 20, that is what, 14. C equals $14. And then when I check it, I'm going to plug it into the 5 times 14 equals 70. I'm going to do the math of 14 times 5 since I used mental math on that last division problem. 5 times 1 is 5 plus 2 is 70. That worked. 70 equals 70. So the cost of each ticket is $14. All right, here's another OYO. Go ahead and pause the video and try it on your own. Write and solve an equation, find the number of rows in the theater. So I'm going to use R. R is number of rows. A theater has 1,200 seats. So I'm picturing the seats, right? There's 1,200 across here. Sorry. Each row has 20 seats. There's 20 seats across here. What I need to know is how many rows. Oh, so it's kind of like the area in the rectangle one, right? When you multiply the number of seats times the number of rows, you're going to get the total seats. Okay, so think of it like this. I already have the 20. I need to know how many rows, and when I multiply those 2 numbers, it equals the 1,200. So let's do this. 20 times R equals 1,200. And when I solve it, I put the balance scale down. I do the opposite of multiplying by 20, which is dividing by 20. That cancels out to a giant 1. I get R equals 10. I'm going to divide the top and the bottom by 10, basically getting rid of a 0. And then I'm going to divide the 12 by 2 and get 6. So I think the answer is 60, right? 60 rows. Oops, R equals 60. And then I'm going to plug in to the original solution. 20 times 60 equals 1,200. Yes, 12 times 2 times 6 is 12 plus 2 zeros. 1,200 equals 1,200. So that is the correct solution. There are 60 rows. Okay, here's another example that I want to do. There's 4 friends. So I'm circling the 4 friends. They earned money. after they divided the money equally, right? So they divided the money equally, and you can see how much they each got. They each received $315. Oh, you might see this problem in the homework, which is why it looks like a multiple choice. Which of the equations could be used to determine T? You don't have any equations. We have to do it on our own. Okay, so we're trying to find the total amount that the 4 friends earned. Ooh, this is important, right? 4 friends earned all together. There's my math word. So all together, okay, well, obviously, it seems like I could add 315 plus 315. I don't want to do that. Let's come up with an equation that uses the variable that they gave me. T is the total amount. So if I take the total amount that they all earned, since it's already defined, and if I divide it by 4, wait, that's not right. Oh yeah, and I divide it by 4 friends, I get the fact that they each get $315. Now maybe you're thinking, wait, that seems really silly. What I should just do is multiply 315 times the 4 people, and that equals T. And that makes sense too. Okay, here's a no-yo. Try this one on your own. Okay, so you're planting seeds. You have a total of $15. Each package costs $125. They're already telling us that P equals the number of seed packets you can buy. So P is the number of packets. Write an equation to find out how many packets you can buy. So hopefully you're thinking of something like this. The word each usually means times, right? So if I multiply 125 times the number of packets I'm going to buy, it should equal $15. Now, maybe I'm going to have to think about if it's not exactly $15, will I have enough, will I have to round up or round down? But that's a good equation to use. Now, maybe you were also thinking, if I take 15 and I divide by $1.25, that would tell me how many packets I could get. I would accept either one of those. Okay, last idea is this. So this is kind of like the hands-on equations, right? I normally don't give you equations that have variables on both sides, but since you had a chance to play around with hands-on equations, I just want you to think about whatever you do to one side, you do to the other. So I have this kind of crazy hard equation here, but I want you to see that you might notice that there's a 5x on this side and there's a 5x on this side. So if I remove 5x from the left side and I take away 5x's from the right side, here's what I'm left with. 3x equals 18. Now you have had all this practice on today's lesson notes in solving problems like this, where there's only one variable on one side, and if I do if 3x's equal 18, if I divide by 3, then I know that 1x equals 6. So try this last one on your own and see what you get for y. Hopefully you're going to notice that both sides have a 2y, so I'm going to subtract 2y. 0 pair, I end up with 8y equals 40. The opposite of multiplying by 8 is dividing by 8. That cancels out, and I get y equals 5. Okay, so the homework is informative. Good luck.